Vertical asymptotes. Consider a function f of x. Sometime when function is approaching a point, it may follow a vertical line. Like if I have, this is the x-axis and this is the y-axis. This side will plot f of x. Consider a point here. At this point, there is a vertical line. And when function is approaching to this point, it can follow this vertical line. Suppose it is coming from left hand side, and then it can follow this vertical line. Now in this case, this function is approaching to positive infinity. So if I consider some value here, suppose it is -1. So we can clearly see that when x is approaching to this side towards x equal to -1, then function value is approaching to positive infinity. Now it may happen that same x-axis, this is your f of x, and here I can have one vertical line. So function can follow the downward direction. Meaning is that this time the function value is approaching to -infinity. So f of x is approaching to -infinity in this case, and in this case f of x is approaching to +infinity when x is approaching to this value -1 here, and suppose it is also -1. So these are the vertical asymptotes, and this knowledge is important. If I have clear concept about vertical asymptotes, we can draw the functions, okay, graph of these functions, we can draw it clearly for any complicated function. Okay, like if I give you this problem, the function f of x is x minus 4 whole square upon x minus 1 times x minus 3 whole square times x minus 5. Can you draw the total function as x is varying from -infinity to +infinity? It's really challenging. But if you follow this video, you will see that it's not difficult at all. I'll show you all the steps, but you need to follow all the steps carefully. Don't skip any part, otherwise you will not understand. Okay, so for this one, the graph will look like this. So I have considered on online GeoGebra graphical calculator. So there I have plotted this function, and this function will look like this. Okay, but in this video we'll try to understand how to draw this function freely with free hand, and the tricks I'll discuss in detail. You'll be able to draw it clearly. Okay, just follow me, and I hope it will be useful for you. Okay, let us start. So first I'll consider a very simple function. Okay, here in this video I'll be considering the function of this form: some numerator p of x and some denominator q of x. Okay, this form is called rational function, numerator as well as denominator. So for example, f of x I may consider, so this is x minus 2, x minus 3, x minus 5 suppose. Here it is x minus 1, x minus 4, x minus 6, x minus 8, like that, this product. Now how to find the vertical asymptotes? Now you see that I have said the function is approaching either +infinity or -infinity at certain point. That's how you will get vertical asymptotes. So to get vertical asymptotes, this vertical asymptote you will get if you solve this qx equals to 0. Because whenever it will be 0, this part will become 0. obviously something by 0 will become infinite, either positive infinity or negative infinity. Thus, this solution q of x equals to 0, at those points, these solutions, you can solve for x, those solutions, there you will get vertical asymptotes. So in this example, so you can easily understand that. So this will be equal to 0 for this problem. This x minus 1, x minus 4, x minus 6 and x minus 8. This product will be 0. So this could be 0 if x is having the value. For this one it is 1, for this one it is 4, or this one it is 6, or it is 8. For any of these 4 value, if I put here in this function, so this function will be something by 0 will become infinite. Okay, means at those places we will be having asymptotes. So like this. Okay, so we are confirmed here that if this is x, this is your f of x, this is x equal to 0. Now see the points here, x equal to 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay, so at 1, 4 and 8 you will be having the vertical asymptotes. Okay, at 1 I can put one dotted line, at 4 there will be another dotted line, this vertical asymptotes, this 6 there is another vertical asymptotes, and 8. Okay, now the graph could be anything. Okay, so right now we are not in position to draw the total graph, just I am explaining what is the asymptotes. Okay, so when the denominator will become 0, that time only you will get asymptotes. So these red lines are the asymptotes, right? And graph could be anything that I am not discussing right now, right? So it could be like this one. So freely I am drawing. It could be like this, and then it is like this. Okay, it could be like this. So that we will discuss in more detailed way, right? Now let me discuss the first problem. Okay, so f of x equals to, this is now example number 1, we'll start. The simplest one, 1 upon x. You know that f of x equals to 1 upon x. This is rectangular hyperbola. So what are the solutions? Where you will find the asymptotes? So these solutions, so here x equals to 0. So this is the vertical asymptotes. So at x equal to 0 you will have a vertical asymptotes. Okay, so we can draw these things. So this is the x-axis. This is the y-axis. You can see that x equal to 0 here. So this y-axis is nothing but it is a vertical asymptotes in this case. Okay. Now you can understand that when x is positive, f of x, that is 1 upon x, that is also positive, right? And this is first case. Second one, when x is less than 0, negative, in that case f of x is again 1 upon x. X is negative, so 1 upon negative will become negative, total is negative. So meaning is that within 0 to plus infinity it is a positive, and within 0 to minus infinity this function is negative. Okay, then at x equals to 0 it is asymptote. So obviously at 0 it will be a positive infinity. Okay, so how can I draw these things? Simply I can draw. So as we know these things, that right side is a positive, so it will start from positive infinity, and as x is becoming large, x is approaching to infinity, you can see that x is approaching to infinity, first infinity, that time f of x is approaching to 0, because 1 upon infinity will become 0. Similarly again, when x is approaching to minus infinity, then also f of x will approach to 0. Okay, so these few informations we are having. So first one, I'll consider this and this. Its right side it is positive and it will start from positive infinity, it will go to 0, right? So the curve could be like this. So freely I can draw. Gradually it is decreasing, not only it is decreasing, it is going towards 0. Okay. Similarly this side, left hand side. Now if it is negative, then this side is negative. So it will start from negative infinity and it will go towards 0. So curve could be like this. So you can see this curve f of x is symmetrical, anti-symmetrical actually. So positive side it's plus infinity towards 0, decreasing. Here minus infinity towards 0. So this is the vertical line. This one is your vertical asymptotes in this case. Okay, I think it is clear. This is all about f of x equals to 1 upon x. Now we'll discuss some more difficult problems. Now next problem, if I consider f of x equals to 1 upon x minus 2. Okay, so what is the vertical asymptotes? So if I use this thing, x minus 2 equals to 0. Denominator I will make it 0. So what is that? X equals to 2. So now I can draw the shape, and that is very simple. This is our y-axis, this is your x-axis. Now you need to put this point x equal to 2. Suppose this is your x equal to 2. So at this point you should draw a vertical line. So this will be your vertical asymptotes. Now you need to understand when it will be positive, which side, and which side negative. So I'll use one sign convention, very easy sign convention. Okay, what is this? So this is your x-axis. Now this is suppose x equal to 0 and this point is x equals to, so here you have one point, no, that 2. So only denominator is 0 here as x equal to 2. Numerator there is nothing. Okay, so if I choose any point here this side, so obviously x minus 2 will be positive. Any point if I choose on right side of this point, testing point, point 2, obviously suppose if I choose 4, so 4, this 4 minus 2, it's 2, that is positive. So any point 5, 6, 7 after infinity, any point, so this side it is positive, and with respect to this one, this side is negative. Okay, so more than 2 it's positive, less than 2 is negative. That's simple. Okay, so how to draw freely now? So you can see that it will start from positive infinity and it will go towards 0 as it is earlier. Similarly, left side is negative, so negative infinity, and it will follow this curve towards 0. Okay, this side. That's all. This is your function f of x equals to 1 upon x minus 2. Right? Now next, take the next problem. F of x equals to 1 upon x minus 2 times x minus 3. Now you can understand what is the asymptotes. So vertical asymptotes. Where? So its solutions x equal to 2. Its solutions x equal to 3. Right? So I have two asymptotes at x equals to 2, another one is x equal to 3. So can I draw this one? Alright, so I'll consider this is the y-axis, this is your x-axis. Now I'll consider this 2 point x equal to 2 here, and this is the point x equal to 3 here. Okay, so there I'll draw the vertical lines. Okay, this one and this one. These are two vertical lines, vertical asymptotes, right? Now, as I said that the very right side, so I have two elements, 2 and 3, right? I'll mark here with this. So this is the element 1, this is the element 2, okay? The right side is always positive. I'll mark with the sign. So this sign, it should be positive. Then it will alternate. In between, it is a negative, and then it is again positive. That's all. Imply that when x is more than 3, it is always positive. If x is within 2 to 3, it is negative. And when it is x is less than 2, it is positive again. Okay, it's alternate. Very right side is always positive. Okay, that I am considering, because if I consider this kind of functions, 1 upon x minus 2, x minus 3 kind of things, right? Now easily we can draw. How to draw these things? So as right side is positive, and we know that numerator is nothing there, denominator is there. So as x is going towards infinity, the function will approach to 0. Okay, so from vertical asymptotes it will start, right? I'll draw these things. So from here it will start and it will go towards 0. Okay, this is one part. Similarly, when x is less than 2, thus it is positive. So here also I can expect it will start from here and it will follow this line, go towards 0. Right. Now within 2 to 3, now this side is negative. So as it is vertical asymptotes, it will start from here, infinity. And here also it will be this minus, okay? So I can expect that from this side it is decreasing, and but it cannot cross the real axis because numerator there is nothing. So there is no 0 for this function. It cannot cross the real axis. So it can have, again, it will have some bending here, it will follow this path. So it can have some maxima here in this case. As it is a symmetrical part, so this is exactly symmetrical, I can expect that this maxima we can have at middle means x equals to 2.5. Okay, so you can find out the value. You can put the f of 2.5. So what is f of 2.5? So it will be 1 upon 2.5 minus 2, and this is your 2.5 minus 3. So this value will be 1 upon, this is your 0.5 and this is your minus 0.5. So it is a minus sign, 1 upon 0.25, that is minus 4. So this value is minus 4. Okay, so you are going to get a maxima at x equals to minus 2.5, and this is complete. So you can see how easy it is to draw this f of x. Okay, so first you need to understand what is the vertical asymptotes. You will start from there and then get the sign, whether it will start from positive infinity or negative infinity, and whether it will cross the real axis or not. Okay, so we'll take more problem. You will become expert in this topic. So continue till the end. You will get everything. So next one, this one. Now I will consider one 0 here, one numerator here. Okay, this part I have introduced. Okay, so when the function will become infinite, vertical asymptotes. So for vertical asymptotes, the x positions will be x for this one, it is x equals to minus 4, and x plus 2 equals to 0 for this thing, it is x equals to minus 2. And f of x will be 0 when x equals to this thing, these solutions, x equals to minus 1. If I put, that means f of minus 1 equals to 0. Okay, so that is also confirmed. But asymptotes will depend on only denominator, not on numerator. So but numerator will give you the zeros, okay, where value will become 0, means roots. So roots of this function will be x equals to -1. I have only one root, means at x equals to -1 the function will cross the real axis. Okay, now I'll draw the complete graph. So first, this is the y-axis, this is your x-axis. Okay, we need to put those values. So this is your -2, this is your -4, okay, and -1 also I need, okay, it's -1. Okay, now what do we understand? We understand that at -2 and -4 we are having vertical asymptotes, so we'll draw the asymptotes. So at -4 I have one vertical asymptotes, another vertical asymptotes is -2, so I'll draw this thing here. Fine. Okay, now I have 3 points, so these points I have noted. Okay, so I can find, so whether it is numerator or denominator doesn't matter, I will consider those points. Now very right side of this point, right side points, that will be positive. So this is positive, means beyond -1 it is always positive. Okay, and this one within -1 to -2 it is negative. Then within -1 to -4 it is positive. Then -4 to -infinity it is negative. It's alternative. Okay, I hope you have got this sign convention. Take the rightmost point and beyond that right side it will be positive, and then take alternative signs. That's all. Okay, now start with the asymptotes. So if I consider asymptotes, this one at -2, okay, means these lines, vertical lines asymptotes, okay, this one I am considering, right? These vertical asymptotes I will consider. Now around these asymptotes, right side you will see the sign is negative and left side it is positive, means right side it will start from -infinity, okay, and left side it will start from positive infinity. Okay, it will come down from positive infinity this side, and right side it will start from -infinity, it will go towards this side. Okay, and here this is on 0. At f of -1 it will become 0, so means it will cross this x-axis at this point. So I can expect it will start from here and it will go through this point. Okay, but again what is happening at infinity, because denominator is more compared to numerator. So if x is moving towards infinity, so you will have 1 upon infinity will become 0. So ultimately it will go towards 0. So then can I draw this thing roughly? Okay, try to understand, this is more critical, right? It will start from -infinity, it will pass through this point, and then it will become positive because sign is positive. But it cannot go towards positive infinity because there is no more vertical asymptotes. Okay, it will go towards 0. So somehow it will go towards 0. Okay, somewhere you may have some maxima here. Okay, in some points, but that is not important for us. So safe is important for us. Okay, now this one what I can do. So next one is this side. You can see this is positive, always it will remain positive, so in this side only. So it will start from here, and from here also it will start from here, so it can have some minima here, this kind of things. Okay, that is the only possibility, right? So can I draw? So it will start from here and it can have some minima here, and then it will go towards this again positive infinity, right? It cannot cross the real axis because there is no zeros, right? Numerator is not there. Fine. And then -4 to -infinity, it is negative, it will start from here, and it will move towards 0 only. That's simple. That's all. So this is the function. This is a graph for this function f of x equals to x plus 1 upon x plus 4 times x plus 2. Right? We'll take more problems. Now can you draw these things? Okay. Don't skip any part. You will get good concept in this video. This will help you to draw any complicated function. Okay. Now, can I consider, so what is the vertical asymptotes? Vertical asymptotes will be at x equals to 2 and 5. And what is the zeros? Or this function is having roots. I can say roots. Roots will be at x equals to 1. Okay, this is the information. So I can now draw. So this is the two axis. This is the x axis. This is the y axis. Right? Now I'll consider these points. This is suppose 1 point, x equal to 1. This is 2. And this is suppose 5. Okay. Now first I will draw the asymptotes. So the asymptotes are 2, there is asymptote, vertical asymptotes, and x 5 there is another vertical asymptotes. Okay. Now I'll get the sign. So how to get the sign? So how many points are there? 3 points. 1 numerator, 2 denominators. So these 3 points I've got it. So right side is positive. Then middle one is negative. Then it's again positive. Then again it is negative. Okay. So what's the meaning? So it will start right side. It will start from positive infinity and go towards 0. That's simple. Okay. And this one is remaining negative. Right? So obviously it will start from here, and here also is negative infinity. So it can have some minima. Then again it will use one curve. It will follow this path. It cannot cross the real axis. Right? Now from this vertical axis, this side is positive. So it will start from here. But this is really 0. It is 0. So it will pass through this point. Okay, then it will become negative, but later it will become 0. So it has to go to this side. Okay, I think it is as simple as that. Okay, next one is this one. Now one interesting thing I have considered. Now these zeros I have considered in between two asymptotes. Okay, can you see the asymptotes, vertical asymptotes? That is at x equals to 1 and 5. And where are the zeros or the solutions of this one? Fx equals to 0, that's the roots. That is x equal to 3. That is in between. Now can I draw? So this is the y-axis. This one is x-axis. Okay, this points I need to consider is 1, 3 and 5. Okay, this is 1 and this is 3 and this is 5. Okay, now we have vertical asymptotes at x equal to 1 and 5. So I'll draw those things first. Okay, so at 1 there is one vertical asymptotes. Another asymptote is at 5, right? And remember, these are the 3 elements. This one, and this one. So obviously this is positive sign, this is negative sign, this is positive sign, this is negative sign. Okay? So what is the meaning? So from this asymptotes, it will start positive infinity. Okay? I'll take different color. So positive infinity here, and it will follow the 0 line. Okay, this is the right side. Now what about this one? This negative sign indicates that it should start from here, and this one is really 0. Okay, at x equal 3 it is 0. So obviously this curve should pass through. So freely you can draw these things, pass through these points. Okay, and then again this side it is going towards positive infinity because this sign is positive. Okay, so it should go towards positive infinity. Is right? And then this side 1 to minus infinity, it will start from minus infinity, and there is nothing, so it will follow this path. I think it's absolutely fine. I think you are getting this more point. Okay, now we'll move to next problem. Now earlier we have considered denominator is always more compared to numerator. Now if I have one numerator, one denominator, so what are the changes? So here, where are the vertical asymptotes? Vertical asymptotes you will get at x equal to 5. And where are the zeros or the solutions of this function if x equals to zeros? Okay, the roots. What are the roots? X equal to 3. One thing is you can note that as x is approaching to infinity, x is approaching to positive infinity, what is happening? F of x. So this time what I can write, this is almost equals to, so 3 I can ignore and 5 I can ignore because x is very large, then 3 is negligibly small. So this is your x, simply ignoring 3. This is also becoming x will cancel and it will become 1. So the ratio will become almost 1. Means f of x is approaching to 1. Okay, not 0. Be careful. Very similarly, when x is approaching to minus infinity, then also f of x is approaching to 1 because they will cancel each other's. 3 and minus 5, minus 3, minus 5, these two I can ignore. So that I should keep in mind. Okay, now how can I draw this one? So this is your y-axis, this is your x-axis. So first the point I'll choose, this is your 3, this is your 5, and I have one vertical axis that is at x equals to 5. So there I have one vertical axis here. That is the first task. I'll put the vertical axis. Okay. Now what is happening? Now the function is approaching to 1 at infinity and minus infinity. That line also I'll draw. Okay. I'll draw that line. So this is suppose one line. So actually this line indicates it's a horizontal line. It's also one asymptote, but this is called horizontal asymptotes. Okay, this horizontal asymptotes we will discuss in detail in the next video. Please let me know in the comments, okay, if you want this kind of video. So these horizontal asymptotes as well as the inclined or slanting asymptotes or oblique asymptotes, that will be discussed in next video if you want. Okay, please let me know in the comments if it's required. So this is the thing. So now we understand that from vertical axis it will start. So what is sign? So put the sign down. So these are the two elements. So this is your right side element. So this is positive, this is negative, and this is positive. Right? So beyond 5 it will take this positive infinity. It will start from positive infinity, but it will converge to plus 1. It will start approaching to this plus 1, this one level. Okay, this is the asymptotes. It will start from this side vertical asymptotes, this side horizontal asymptotes. Okay, and then within 3 to 5 it is negatives, so it will start from minus infinity. Okay, and this is exactly 0. these solutions. So it will pass through this point, and finally it will have the minus infinity. At minus infinity level, it should be equals to, function value should be equals to 1 again. So can I draw like this? It is now approaching to this line. Be careful, okay, because of this one. Okay, this is the only change. When you are having both numerator denominator order is same, okay, then you will get the horizontal vertical line that could be non-zero. Okay, it will be non-zero. So in this case it is 1. So this value is 1. Fine. So this is example number 7. Now we will discuss more. This one, can you draw the function for this one? Okay, I have 2 zeros and denominator is also order is 2. So this is sometimes called poles. Okay, so asymptotes, vertical asymptotes, 2 vertical asymptotes. What is that? X equals to 2 and 4. This is for 2 and this is for 4. And the roots will be at x equals to 1 for these things, and for this one it is 3. Okay, now I can draw. It's very easy. So this is one y-axis, this is one x-axis. So I need to put the points here. So this is also 1, this is 2, this is 3, and this is 4. Right? Now these 4 points I will consider. First I will show the asymptotes. What are the asymptotes? So this line I will consider. So at 2 and 4, at 2 I have one asymptote, another asymptotes at 4. Now as this system, this function is having numerator denominator same, so obviously it is approaching to 1 rather than 0 at infinity, when x is approaching to infinity. So I will have one horizontal asymptotes. So I will put that asymptotes here. Okay. So now I can draw these things. So how can I draw this? So now be careful here. So right side, so first get the sign. So how many elements are there? These are the 4 elements. This one, this one, this one, and this one. So right side is positive, then it is negative, then it is positive, it is negative, then it is positive. So it indicates that beyond 4 it is positive. It will start from positive infinity from vertical axis. Okay. So this side, and it will follow simply this horizontal one for the 1. This is the 1 level. Okay. Right. Then immediate one, 3 to 4, it is negative. So it will start from negative infinity. But this one is, it's actual 0. So it will pass through this point. Okay. Then right side it is following, we are having at 2, one is one vertical asymptotes, but it's positive, so it is going towards positive infinity. Okay, fine. Then less than 2, 1 to 2, it will start from minus infinity. Okay, then this is actual 0, so it will go through this point. Then the asymptote is 1, when the asymptote is 1, so it will follow this path. Any difficulty? I think it's clear, very clear. Okay, we can draw this kind of function very easily. Okay, now let us consider mode function very quickly. Okay, this one, can you draw it very quickly? One interesting thing is there. Okay. Now, what are the vertical asymptotes? This is at x equal to 1 for this one, and at x equal to 5 for this one. And what are the roots? Roots are at x equals to 2 for this one and 3 for this one. Okay, now can you draw? So this is the y-axis, this is your x-axis. I need to put the points. This is 1, 2, 3, 4, 5. These are 5 sufficient points I have considered. Okay. Now where is the vertical axis? 1 and 5. Okay. I need to indicate that one. 1, there is one vertical axis. And 5, there is one more vertical axis. And I have zeros 2 and 3. Okay. Now what are the elements? How many elements are there? So this is one element 1, the element 2, element 3 and element 5. 4 is not element. Be careful. Though I have marked here, 4 is not any element. Okay. This is only 4. This is 1, 2, 3 and 5. Right. So right side element, that side, right side of that right is most, rightmost. Okay. That is your positive. Then this is your negative. Then this is positive, this is negative and this is positive. It's fine, the sign convention. Okay. Now as numerator denominator both are same, second order, so I will have horizontal asymptotes, so that I can draw. This is the horizontal asymptotes. So it's very simple now, we can draw. So how to draw these things? So right side vertical asymptotes, it will start from positive infinity, it will go towards this one. Okay, that's simple. Now this is exactly 0, so then it will start from here, minus infinity, right? And this thing, so it will try to cross this point, because this is one 0, real 0, this is another real 0, but you see that this is again negative, means it will start from negative. Okay, but it will cross these 2 points and then it will become positive. Okay, that means that it will come to this point and it will become positive a little bit more, and then again it will go to this side, it will follow these vertical asymptotes. Okay, so this peak, this maxima, it will not cross the 1. So are you convinced? This value cannot be more than 1 for this function. Okay, please comment below if you can get these things, right? So my claim is that this point is below this horizontal asymptotes. It cannot cross that one. Okay, but that is not the point here. So this is the sketch here. Now right side, now it is very simple. It is a positive, so it will start from positive infinity and it will follow these asymptotes, horizontal asymptotes. That's all. This is now complete. Okay, now we'll move to the next problem. Now sometimes the second order equation form it is given. So first task is to find the factors for this one. So what are the factors? So what are the denominator factors? Can you have the factors? I think it's very simple. One is x minus 1, one factor, another one is x minus 5. So what is the vertical asymptotes? Is it at x equal to 1 and 5? Okay, that we will check little later. Okay, so now what are the factors for numerator? X minus 1, x minus 2. Is it correct? Now you can see here one important thing. This x plus 1 minus 1, x minus 1 is getting cancelled out. Both numerator is present, both numerator and denominator. So meaning is that x equals to 1 cannot be on vertical axis. So vertical axis is only x equals to 5, not 1. Be careful. X equal to 1 is not vertical axis. So this one is almost equals to x minus 2 upon x minus 5. Same thing. If we cancel these two, x minus 1 factors. Okay. Now we can easily draw the function. So here is one tricks. So this is your x-axis. Now I will consider these 2 points, x equal to 5 and x equal to 2. These two are sufficient. Okay. And we have one vertical asymptotes at 5 only. Okay. So as numerator denominator same, I will have one horizontal asymptotes, that is 1. This value is 1. So now I can put the sign. So this is only 2 elements. I will not consider 1. Okay. So this side is positive, this is negative, this is again positive. Okay. It's implied that when x is more than 5, it will start from positive infinity, it will go down to plus 1. Okay. And left side, it will start from minus infinity. Okay. And it will pass through this point because this is 0. Obviously it will pass through this point and it will try to follow this part. But here is one issue. So at x equal to 1, it is cancelled out. Okay. So there is a point x equal to 1. That time actually this function is not defined at x equal to 1. So I need to put one mark here to indicate that it does not exist. So at this point there is a hole at x equal to 1. So function value does not exist. Otherwise this is perfect. Okay, this is the only difference. So if you have some cancellation numerator denominator factors, that you will do first, then draw this one. But where you are having some cancellation, there you will put some mark that it is discontinuity at this point. Okay, right. Next one. Now question is that sometimes we have considered right side asymptote starting from positive infinity, left side negative infinity. Is it possible it will start from both sides positive infinity? That is the case. Okay. Now you can see here. So if I want to draw these things, this is your x. Now you can look at these things. So what are the asymptotes? The asymptote is x, vertical asymptotes is x equals to 0. So y-axis is vertical asymptotes. Okay. Now when x is positive, x is more than 0, then fx is also more than 0. This is thing. And when x is less than 0, that time also fx is positive because its square term is there. Okay. Meaning is that it will start from positive infinity here, it will start from positive infinity here, and it will go towards 0. This side, and it will be this side. Okay, that's all. So this is at 0, x equal to 0, 1 upon x square. Okay, this is the vertical asymptotes at x equal to 0, and at both sides it will start from positive infinity and it will go towards 0. Right. Now can you draw this problem? So now you have got the concept. If there is a square terms, you have to be careful. Okay. So can you draw this function, total functions? Okay, that I will try. So this is your x-axis, this is your y-axis. Okay. Now the points. What are the points? So the points is x equal to 1, 2, 3, 4 as well as 5. These are points required. Now what are the asymptotes, vertical asymptotes? Can I consider vertical asymptotes where x equals to this, for this one it is 1, for this one it is 3, For this one it is 5. Don't consider two vertical asymptotes at x equals 3 because it is basically one vertical line only. Okay. So what I will do, I will draw those vertical lines, right? So at x equal to 1 vertical line, x equal to 3 another vertical line, x equal to 5 another vertical line. Okay. Now sign convention is most important here. Okay. So what is the elements? Be careful. Okay. This is one element, 2 is another element, 3, but 3 square term is there. Be careful. 4 and 5. Okay. So rightmost side only x minus 5 is there, so this is positive. And then x minus 4, so this will be negative as usual, is fine. Because that x minus 4, x plus 5 will make negative sign. Because of that only this sign is becoming negative. Okay. And x minus 4 left side, it will be alternating again, it is positive. But be careful at this point x equal to 3. Because this square term is there. Because of that, both sides it will remain same. So if the right side is positive, if left side will remain positive, no sign change. If there is a square term, its right side and left side would remain the same sign. Okay, so 2 to 3 again it is positive. Then again it will continue. It is positive, then it is negative, then again it is positive. Is it right? Now we have got these total things. Now we can freely draw the graph. Okay, so can I draw the graph? So right side vertical asymptotes, and you see denominator order is more compared to numerator order, so really it will go to 0. It will start from here and it will go towards it. There is no horizontal asymptotes. Horizontal asymptote is there, that is the x-axis only. Okay, none other than 0. Right. Then it will start from at 5 vertical asymptotes negative sign this side. I have 0 here, so it will cross this point, and then it will go towards positives this side. So as usual, so it will go towards this side and it will follow this one. It will go towards positive infinity, right? And now then it will happen, it is again positive sign, so it will start from positive infinity, and it is 0 here, this one 0, so it will pass through this point. Then it will follow this axis negative side, it will go toward this side. Okay, and then this is positive, it will start from positive infinity this side and it will go towards 0. It's complete. So this is the function, this is the graph for this function. Okay, are you convinced? Take the one more problem, this one. Both square term is there, square term is here, square term is here. So can you draw? Okay, this is y-axis, this is x-axis. So what are the points? So points are 1, 2 is not there, fine. It's 3, then 4, and then 5. Okay, what is the vertical axis? Vertical axis will be, for this one x equals to 1, for this one it's 3, for this one it's 5. Again 1, 3, 5. So I can draw those vertical axes first. 1 at 1 vertical axis, 3 on vertical axis, and then 5 another vertical axis. Okay, now put the sign convention, that is the most important part. Okay, this is one element, this is one element here, so here two elements. Okay, be careful, square term is there, this is 1, so this is positive, so this is negative, because 5 at 5 only 1, not square term. Okay, but at 4 it is square term, because of that right side is positive, negative, so left side will be also negative. Now 3, now next one is coming is 3. Now what is 3? Right side is negative, so that is a square term, so it should be again negative. So be careful, okay? Then this one, there is no power, only power is 1, so it will now become positive. Now can you draw? Okay, now you see the order of denominator is more than the order of numerator. Okay, so I can now draw the function. So it will start from here, point infinity, it will go towards 0. Okay, now what will happen here? So this is exactly 0. Okay, at 4 there is a 0, so it will start from minus infinity and it will come up to this point. Okay, but again it cannot cross these things, it cannot become positive because this sign is negative, so again it will go towards this side. This kind of bending you will get it. Okay, now another vertical asymptotes at 3, so it will start from again this side, and here also it is minus infinity, but it can, there is no zeros here. Okay, no roots here, only like this. So its meaning is that you will have some bending like this, but it cannot touch or cross the x-axis. It could be like this. Okay, so this value we can find out. This is one maxima, this is another maxima. So taking derivative, all those things we can find out extrema. That is not the part of this video. Okay, now next one, this asymptotes 1, this side it will start from this one and it will go towards 0. Right? So this is the complete graph for this function. Is it too difficult to understand? Okay, so initially I have shown this figure from GeoGebra. You see this curve, it is exactly same thing as last one that we have discussed. Okay, I hope you have got this idea. Now one more problem, I will consider these things. This is the final one. Okay, now will you find any vertical asymptotes? Will it become 0? So x square plus 1, it cannot be 0 because this square term is there. It's always more than, so x square plus 1 is always more than 1, no? So it is always positive, so it cannot be 0. We can't make it 0. So there is no vertical asymptotes. That is important thing, very important thing. So it's not that every time you will get vertical asymptotes, if denominator is there. No. So if it cannot make it 0, so there is no vertical asymptotes. Okay, for that case, so what is happening? What is the graph for this one? So this graph is easy, little bit. This is x. Now at x equals to 0, what is the value? So 1 upon 0 plus 1, that is equals to 1 upon 1 is 1. So it will start from 1. Okay, so how will you follow these things? So from here, so as x is increasing, I can say that x is increasing. What is happening? Function f of x is reducing because denominator is increasing, function is reducing. At infinity it will become 0. So I can expect that this kind of curve, it is approaching to 0, right side, and it will be symmetrical because square term is there. Okay, this is the function f of x equals to 1 upon x square plus 1. But there is, main concept is that there is no vertical asymptote. That is important. Okay, I think you have got the concept of vertical asymptote. So if you want horizontal asymptotes and oblique asymptotes or inclined asymptotes in the next video, please make comment in below. I'll make one video for you. Thanks for watching. Stay connected. I'll be discussing more problems. Thank you.